Hello everyone, a very good evening all of you and a very warm welcome to you all to this wonderful session of fluid mechanics. कैसे हैं सब लोग? Knock knock. Please guys do join me fast because today's session is going to be very crucial, very important for all the mechanical as well as civil aspirants. Please do let me know if my audio and visual quality are fine. Guys, you are watching me live through the foundation course which we are running free of cost for all the GATE 2025 aspirants, and every day at 6 p.m. we are meeting on this YouTube platform, Byjus Exam Prep YouTube channel for civil and mechanical engineers, for discussing the very important and fundamental concepts of fluid mechanics. And today we will be talking about hydrostatic law. क्या जानते हैं आप hydrostatic law के बारे में? Meanwhile, please do let me know if my audio and visual quality are fine, so that बीच में audio video problem की वजह से हमारा session disturb ना हो, so that we can rectify the problem beforehand. Everybody, do mark your presence by writing in the comment section. कल हमने डिस्कस किया था पास्कल लॉ. इफ यू आर पार्ट ऑफ माय यस्टरडे सेशन, yesterday we have discussed about very important law of pressure, that is Pascal's law. जिन लोगों ने मिस कर दिया था कल का सेशन, they can watch the recording using this YouTube link, right? और कुछ क्वेश्चंस भी मैंने दिए थे. So if you have anything to discuss regarding yesterday's session, you can just let me know here. I will be more than happy to help you out in every possible way to make your concept simple, easier for you to understand. Today we will be talking about hydrostatic law, और कल हम बात करेंगे hydrostatic forces, that is the application of Pascal law and hydrostatic law. That is the application of pressure equation. Hydrostatic force are nothing but the pressure forces. Pressure forces. Tomorrow at 6 p.m. and day after tomorrow we will be talking about the last concept of fluid statics, that is the concept of buoyancy and Archimedes principle. बताइए मेरी आवाज आ रही है आप लोगों को? It is my humble request every time. मैं स्टूडेंट से यही रिक्वेस्ट करता हूं कि those who are watching me live, those who are investing such a crucial time to understand the concept, to attend this live class, please keep on having the communication, keep on talking to me, so that the session become more informative, more important, and will help you to improve your fundamentals. All right. जो लोग पहली बार मुझसे मिल रहे हैं, दिस इज माई क्विक इंट्रोडक्शन. I am mechanical engineering graduate from IIT Delhi. I graduated in 2006. I have also cleared engineering services examination in 2009. I have worked in SAIL for more than 2 years, and more than 2 years of experience I am having in a private consulting firm. So it is around 4+ years of industry experience, and from last 11 years I have been into teaching, guiding the students who are preparing for various competitive examination. Right? Am I audible? Can you guys hear me? Yes. Fluid mechanics, heat transfer, thermal and industrial engineering are my favorite subjects. Fluid mechanics is common for mechanical and civil engineering. So that is why the session is very important for all the mechanical engineers as well as all the civil engineers who are preparing for GATE examination for 2025. You can always connect with me through my mail ID. This is my official mail ID. And if you have anything to discuss, you can join me on the Telegram as well. My Telegram link is Mechanical by Chandrasekhar, and you can join using the link below, or you can just scan this QR code. Yes, You can scan the QR code also to join me on the Telegram. More than 1500 students are already part of my Telegram channel who are preparing for GATE, engineering services and other competitive examination. So with this group, you will definitely get positive energy, motivation and all kind of support from our side as well as from the student side to clear the competitive examination. Yes, Chandrasekhar, Kitali Chandrasekhar, welcome to the session. I welcome you all once again from the bottom of my heart to this wonderful, fruitful and very informative session for all the civil and mechanical engineers who are preparing for any of the competitive examination, be it GATE, ESE and other PSUs. Namaskar, Adab, Shubh Sandhya, good evening, Sat Sri Akal, Assalamu Alaikum, Vanakkam. Shall we start? Are you all ready with your pen, notebook and calculator? These are important to make the session more fruitful and more better. Shall we start? So as always, I ask you a basic and the simple question before I start sharing my knowledge about the hydrostatic law or for that matter about the fluid mechanics. My question to all of you is, I want everyone's opinion, which is having more quantity. Will it be the blood pressure, human blood pressure, which is more? Will it be blood pressure? Or is it the atmospheric pressure? Yesterday I told you about the atmospheric pressure. The atmospheric pressure is the pressure which is exerted by the atmosphere or the environmental mass. Or you do not have any idea about the same. Bataiye, what do you think? Which is having more quantitatively, which is more? Is it the human blood pressure, the pressure which is carried by the human blood, or the pressure exerted by the human blood in the blood vessels, or the atmospheric pressure, or no idea? Yes, everybody. I want everyone, those who are here, to respond. Then we will start our wonderful session. Yesterday I talked about the Pascal law. If you are not very much comfortable with the Pascal law, let me recall or summarize yesterday's concept. According to Pascal's law, in a static single fluid, pressure remains same in a horizontal plane. That was given by the Pascal. That information was given by the Pascal and the law is known as Pascal's law. The pressure remains constant in a horizontal plane in a static and single fluid. If there are multiple fluid, then the pressure may not be same in a horizontal plane, right? So I will reveal the answer to this question later on in our discussion. So stay tuned till the end of the session and please do not forget to like and share this session. So let us start talking about the hydrostatic law. Pascal law talks about the pressure remaining constant in a horizontal plane. If I say according to Pascal law, in a single static fluid, in a single plus static fluid, in a single and static fluid, pressure is neither be a function of x nor be a function of y. Pressure will be constant in xy plane. Xy plane is horizontal plane. What is xy plane? Xy plane is nothing but the horizontal plane. So pressure remains constant in a horizontal plane when it is about a single static fluid, right? That is the continuous mass of same static fluid. Now a hydrostatic law talks about the variation of pressure in a vertical plane. how the pressure varies in vertical plane, that is given by the hydrostatic law. उसको समझने के लिए, to understand the variation of pressure in z direction, again in a single static fluid, we are talking about a single and static fluid. That is important. In a single static fluid, how the pressure varies in a vertical plane. ये समझने के लिए we will be having a fluid element. It is a static fluid element. If we take a static fluid element, you can see this element of dimension dA is the area and dz is the height. This is dz and area will be, let us say, dA. dA will be the area, dz will be the height. dA by dz. It is a static fluid element. dA is the area, dz is the height, and the fluid element is lying at a depth z from the free surface. Let me call this to be the free surface. This distance is, let us say, z. At a depth z, the fluid element is lying, right? Do you understand it? Now, at a depth z, if I assume the pressure to be P, pressure is, let us say, P. At a depth z, the pressure is, let us say, P, then the pressure force will be PdA. On the top, the pressure is P, and the direction of pressure force will always be normal and compressive. So the pressure force will be acting downward. Yes or no? P into dA will be the pressure force. Yes? And at a depth z plus dz, at a depth z plus dz, at z plus dz depth, at a depth z plus dz, what should be the pressure? Will it be more or less? Will it be more or less? Pressure is, let us say, P dash. P dash. P dash. We do not know whether P dash is more or P dash is less. So, according to Taylor's theorem expression, where P dash can be written as P plus del P by del Z into dz. That is called as Taylor's theorem expansion. That is known as Taylor's theorem expansion, right? P dash will be equal to P plus del P by del Z into dz. This is known as Taylor theorem expansion. So the force due to P dash, if we talk about the force, look, this was the free surface. So P into dA was like this. This was P into dA, P into dA, and P dash will exert an upward force, normal and compressive. That will be P dash into dA. What else? What is the other force acting on the fluid element in vertical direction? We are interested in the forces acting in vertical direction. What is the other force? Can you let me know? Yes, everyone. What will be the other force acting on the fluid element other than these pressure forces? It will be, yes, yes, please do let me know. What else? It will be. Do not forget to mention the weight of the fluid element, which always acts in downward direction. Hi Ramesh, welcome. So other than the pressure forces, there will be weight of the fluid element which is acting in downward direction. Now if we apply Newton's second law, if we apply Newton's second law, what is Newton's second law? Net force acting is equal to mass into acceleration. It is a vector equation. And if we apply in vertical plane or if we apply in z direction, then what we will get? What are the forces? P into dA plus P dash into dA, sorry, P dash into P plus PdA in plus W. फ्रिक्शन कहां से आ जाएगा? No, Chandrasekhar, there is no friction. It is a static fluid element. It is not moving at all. Friction comes into picture when there is a relative motion or when there is a tendency of relative motion. Friction force नहीं आएगा. pressure force and the weight of the fluid element minus P dash into dA is equal to mass, that is dm, into acceleration. Do you agree? Acceleration in z direction, because it is a static fluid element, or because it is a static fluid, do you guys agree that acceleration will be 0? Because of static fluid element, acceleration will be 0. So we can say P into dA plus W is equal to mass, that is density, into volume, volume is dA into dz, into G, minus P dash, that is P plus del P by del Z into dz is equal to 0. Sorry, into dA also. Do you agree? Into dz into dA will be equal to 0. This will be the expression. Yes or no? If anybody is having any doubt so far, please do let me know. So dA getting cancelled out everywhere, and this P is getting cancelled out with this minus P, and we are left with del P by del Z into dz is equal to rho into G into dz, and dz are also getting cancelled out. So what we are getting is del P by del Z is equal to rho G. Are you getting it? And as the pressure is not a function of x and y, pressure is constant in a horizontal plane, that is Pascal law. Pressure remains constant in a horizontal plane, that is Pascal law. So we can say pressure is a function of z only, और क्योंकि pressure सिर्फ z का ही function है, so partial derivative of P with respect to z is same as the total derivative of P with respect to z. Partial derivative and total derivative, one is del, another is d. D is the total derivative, del is the partial derivative. So our final expression of hydrostatic law, our final expression for hydrostatic law says that dP by dz is given by rho g. This is the hydrostatic law. When z is measured in downward direction, it will be plus rho g. When z is measured in upward direction, we will get minus rho g. That is the Pascal law. This is how pressure varies in z direction. This is the slope. We can easily find out P versus Z. dP by dz is the slope of P versus Z curve. Yes or no? Is this clear? Every one of you, do let me know. Is it all fine with everyone? किसी को कोई doubt, कोई confusion, please do let me know. Is it all fine? dP by dz is rho g or minus rho into g. What is rho? Rho is the density of the fluid. What is the unit of fluid density? That is kg per meter cube, and g is acceleration due to gravity. And the value is, what is the value of acceleration due to gravity? It will be 9.81 मीटर पर सेकेंड स्क्वायर. कई बार हम इसको 10 भी ले लेते हैं. What is the unit of dP by dz? Who will tell me the unit of dP by dz? What is the unit of dP by dz? That will be Pascal per meter, isn't it? Or it will be Newton per meter cube. Yes or no? Or it will be kg meter per second square multiplied by meter cube. Sorry. Isn't it? Newton is kg meter per second square. So it will become, that will become kg per meter square सेकेंड स्क्वायर. कई बार क्वेश्चंस में यूनिट और डायमेंशन के बारे में भी पूछ लिया जाता है. m1 L-2 T-2 will be the dimensional formula for dP by dz. That is the slope of P versus Z curve. Is this all clear to everyone? Pascal per meter or Newton per meter cube or kg per meter square second square, or the dimensional formula is m1 L-2 T-2. Right? Now, whenever we talk about a fluid, listen very carefully. The fluid can be compressible or the fluid can be incompressible. Do you know the difference between compressible and incompressible fluid? When do we say the fluid is compressible? What does that mean? If the fluid is compressible, what do you understand by that? For a compressible fluid, if we modify the hydrostatic law, what is the information we will be getting? To understand that, let us talk about the compressible fluid. Compressible fluid means density is not constant. For a compressible fluid, density will not be constant, or we can say rho is equal to P by RT. So we can say that is the ideal gas equation. If you understand ideal gas equation, density P is equal to rho RT or rho is equal to P by RT. So P rho is a function of pressure and temperature. Density is a function of, for a compressible fluid, density is a function of temperature and pressure. You must be knowing. For a compressible fluid, density is a function of temperature and pressure. So rho will be given by this expression, right? Now, if we talk about the hydrostatic law, dP by dZ is equal to rho into G, that is equal to P by RT into G. Separate the variables. If we separate the variables, then we can say dP by P is equal to G by RT into dZ. And if we integrate this to get the expression for P versus Z, then at Z is equal to 0. That means the free surface, the pressure is P naught or P atm. And at any height, depth Z, the pressure is P. So what we will get, the left hand side is ln of P by P naught is equal to G by RT into Z, or ln means base E. So we can say P is equal to P naught e to the power Gz by RT. So how is the variation? Pressure varies with Z. What is the variation of pressure with Z? Isn't it exponential? A question was asked in GATE exam previously. In case of compressible fluid, how the pressure varies with depth or height. What is the nature of variation of pressure with depth and height when the fluid is compressible? Your answer should be exponential. The variation of pressure with height or depth will be exponential when the fluid is compressible. Yes, Kumar, is this clear? I hope it is clear to everyone. Can we proceed further? We are not going to discuss about the compressible fluid as such. I just wanted you to understand the nature of variation of pressure with vertical distance, be it height or be it depth. Now, if we talk about the incompressible fluids, liquids are incompressible. Density is constant. Liquids are always incompressible. For incompressible fluid, if the density constant, according to hydrostatic law, we can say dP by dZ will be constant, because G is already a constant parameter. Acceleration due to gravity is constant, 9.81. So when dP by dZ becomes constant, then the variation of pressure with Z will be, what is the nature? When the slope is constant, the variation of curve will be linear. So because dP by dZ can be positive constant or negative constant, so it can be linearly increasing or linearly decreasing. I told you positive comes when Z is measured downward, when Z is a depth, and it will be negative when Z is a height, isn't it? So positive means increasing, negative means decreasing. So pressure will increase with depth and pressure will decrease with height when positive means increasing and negative means decrease. So this is the final conclusion regarding the hydrostatic law. This is our final conclusion. In a static, hydrostatic law and Pascal law are only valid for the static fluid. In case of a static incompressible fluid, means the liquid pressure increases linearly with depth. Depth means Z is measured in downward direction and decreases linearly, the variation is linear for incompressible fluid with height. But for compressible fluid, like gases are compressible, for compressible fluid the variation is not linear, the variation is always exponential, increasing exponentially with depth, decreasing exponentially with height. I hope this is all clear to everyone. Any doubt, anything to ask? You guys are most welcome. बताइए, किसी को कोई कंफ्यूजन सो फार? सो हमने पास्कल लॉ में हमने पढ़ा था द प्रेशर रिमेन्स कांस्टेंट इन ए हॉरिजॉन्टल प्लेन in case of a static and single static fluid, whereas the pressure varies in vertical plane in a single static fluid. It increases with depth, decreases with height. But if the fluid is incompressible, the variation is linear. If the fluid is compressible, the variation will be exponential. I hope it is all clear up to this. किसी को कोई confusion, किसी को कोई doubt? Right? Good to go. Now let us have an understanding of. Now, when density is constant, we are talking about liquids only. When the density is constant, how to find out the pressure at a depth h from the free surface? If a point is lying at a depth h from the free surface, how to find out the pressure? Look, as we know, dP by dz is equal to rho into g. dP by dz will be rho into g. We can separate the variables here. dP is equal to rho into g into dz. Now if we integrate it, can we say free surface means z is equal to 0, that is our reference, and at a depth h is z is equal to h because z is measured in downward direction. Because z is measured in downward direction, we are using plus sign. If we integrate this from z is equal to 0, the pressure is P atm. The pressure here is P atm, yes or no? And at a depth h, the pressure is, let us say, P. So if you simplify this, P minus P atm is equal to rho is constant, g is constant, integration of dz from 0 to h will be h, rho g h. This is the absolute pressure. Do you remember the difference between absolute and atmospheric, absolute and gauge pressure? Absolute pressure at any point is equal to atmospheric pressure at that location plus the gauge pressure, and the gauge pressure is equal to P absolute minus P atm. Yesterday I told you this relationship. So this is nothing but the gauge pressure at a depth h is simply given by rho of the fluid. Density of the fluid is, let us say, rho f into g into depth from the free surface. H is the depth from the free surface. Do you agree? H is the depth of the point from the free surface. Depth from free surface. Depth from the free surface. This is what is our expression for pressure at a depth h. If nothing is given, we always calculate the gauge pressure. If nothing is mentioned, then we calculate the gauge pressures. I hope it is clear. कोई डाउट है तो मुझे बताइए, कोई तकलीफ, कोई परेशानी to understand any of the concept which I have shared so far. Now it will be your turn. So the pressure is given by simply rho of the fluid into g into h, isn't it? So there is the unit of this parameter is Pascal or Newton per meter square. The unit of this parameter will be Pascal or Newton per meter square as long as we are putting the given parameters in their SI unit. Rho is in kg per meter cube. G is 9.81 into meter per second square, H is in meter, then we get pressure in Pascal or Newton per meter square. So from here we can also write H is equal to P by rho G, yes or no? H will be equal to P by rho G, isn't it? So this is another way of representing the pressure. That is, the pressure is measured in terms of pressure head. It is known as pressure head. What is pressure head? The unit is meter. Pressure head is, it is the pressure measured in terms of fluid column. It is the pressure measured in terms of fluid column. That is known as pressure head. Right? Pressure measured in terms of fluid column. This is the static pressure. Static pressure is written in terms of fluid column. It is written in terms of fluid column. For an example, pressure अगर पास्कल में given है तो we can easily calculate the pressure head, static pressure head, or if the pressure is given in pressure head, we can easily calculate the Pascal. For an example, let me take an example. If the pressure at a point is 200 kilopascal, if pressure at a point is given as 200 kilopascal, right? Pressure at point A is given as 200 kilopascal. If we want to calculate in terms of water column, if we want to write the pressure in terms of water column, so in terms of water column, that is equal to 200 into 10 to the power 3, that is P, by rho of water. Density of water is 1000 into G. Let me take as 10 only. So it will be around 20 meter of water column. The pressure at A will be almost 20 meter of water column. 200 kilopascal is equivalent to 20 meter of water column. 200 kilopascal is equivalent to 20 meter of water column. Right? What is the physical significance? If we take water in a container up to a height of 20 meter, if we take water in a container up to a height of 20 meter, it is an open container up to a height of 20 meter, then the pressure at the bottom, PA will be 200 kilopascal. If it is water, if we take water in a container, open container, and the height of water column is 20 meter, then the pressure at A will be 200 kilopascal. That is the meaning. So the pressure can easily be written in terms of meter of water column, or it can be written similarly. If PB is equal to 50 meter of mercury, if pressure at B is 50 meter of mercury, can you convert it into Pascal? So if you want to convert the pressure head into Pascal, pressure head of mercury is given. If you want to convert it into Pascal, then rho of mercury 13,600 into 9.81 into 50, that much is the Pascal. So pressure which is given in pressure head of column, fluid column, can be converted into pressure in Pascal. Right? Hi Asif Ali, welcome. Good evening. Is this all fine with everyone? So sometimes they play with the units and dimensions as well. Sometimes they frame the question in such a way that students get confused with conversion of pressure head into pressure or pressure into pressure head. For an example, if I ask you what is the atmospheric pressure, if I ask you atmospheric pressure, what is the value of atmospheric pressure? Atmospheric pressure is 1.013 bar, yes or no? Atmospheric pressure is 1.013 bar. If we want to convert this atmospheric pressure in pressure head of water, then it is around 10.3 meter of water, if you are aware. And if you want to convert it into mercury column, it will be 760 millimeter of mercury. The standard atmospheric pressure is 1.013 bar, or it is 10.3 meter of water column, or it is 760 millimeter of mercury column. And what is the blood pressure? What is the pressure of the blood? It is 120/80 millimeter of mercury. It is given in mercury column. So blood pressure is 120/80 millimeter of mercury. 120/80 mm of Hg. That is the normal blood pressure. So my question is still the same. Is the atmospheric pressure more or the blood pressure? Now can you tell me, will the atmospheric pressure be more or blood pressure? Yes, every one of you. Whenever you compare the pressure, then you need to convert in a single unit. That is important. Now my question to all of you is still the same. Is the blood pressure is more? Is the blood pressure more or the atmospheric pressure? कौन ज्यादा है? यहां से तो कंपेयर कर सकते हैं. एक है 760 मिलीमीटर ऑफ मर्क्यूरी और एक है 120 मिलीमीटर ऑफ मर्क्यूरी. विच इज मोर? यहां से देखने पे लगता है एटमॉस्फेरिक प्रेशर इज मोर, और यहीं पे गलती होती है. दिस इज द गेज प्रेशर वैल्यू. This is the gauge pressure. Blood pressure is the gauge given. It is the gauge given. It means it is more than, it is 120 millimeter of mercury more than the atmospheric pressure. It is the gauge value. Gauge pressure plus atmospheric is equal to absolute pressure. It is gauge pressure means more than the atmospheric pressure, isn't it? So that is why your answer was correct, that it is always, your answer was right, that it is always the blood pressure which is more than the, it is always the blood pressure which is more than the, blood pressure is always more than the atmospheric pressure, right? So do not get confused with the numerical values, because the blood pressure is given as the gauge value. Now, अब आपका turn. Sorry. Blood pressure is more than the atmospheric pressure. So we can say absolute pressure of the blood. If I ask you what is the absolute pressure of the blood, then it will be atmospheric pressure plus the gauge pressure. So atmospheric pressure is 760 mm plus 120/80 millimeter of mercury. So this is how the blood pressure is having a greater quantity than the atmospheric pressure. Now let us use the hydrostatic law for a different situation. If there are multiple fluids, if we want to find out the pressure at a depth h, let me take multiple fluids. Let us take this way. Look. Look. This is the free surface. This is, let us say, ρ1 fluid, and this height is h1. And the remaining is ρ2 fluid. This is ρ2 fluid, and this height is h2. h2. There are multiple fluids, ρ1 and ρ2. This is ρ1 and another fluid is ρ2. This is, let us say, ρ2. Now how to find out the pressure at a depth h? How to find out the pressure at a depth h for the multiple fluids? So what we will do? It is the free surface pressure is equal to 0, isn't it? Gauge pressure is 0 at the free surface always. So start with the free surface. At the free surface, the pressure is 0. Yes, Asif, blood pressure is more. At the free surface, now try to understand how to calculate, how to write the pressure at a depth h. Here, the value of P at a depth h from the free surface. Now 0 is the pressure at the free surface and pressure increases with depth. We are moving in downward direction in the static fluid, so pressure will be more than 0. Pressure will be more, and pressure is given by, according to hydrostatic law, pressure is given by rho gh, isn't it? Pressure is given by rho gh for the incompressible fluids. All are incompressible fluids. So because we are traveling in rho 1 fluid, so it will be rho 1 into G into H1. If I ask you what is the pressure at this location, if the question is asked to find out the pressure at this location, at the interface of rho 1 and rho 2, your answer will be rho 1 G H1. Now our objective is to reach at point P. So we are further moving in downward direction. So again pressure will increase and pressure is written by rho GH. Now we are traveling in rho 2 static fluid. So it will be rho 2 now into G, and how much distance we are traveling? What is this distance? Isn't it? How much is that? That is H minus H1. Isn't it H minus H1? H is total, then H1 is this. So it will be H minus H1. That is the value of P. That is equal to P. That is the gauge pressure. Gauge pressure at a depth H will be given by this expression. Do you agree or not? Or at bottom, if we want to write at the bottom, what will be the pressure? So start from the free surface 0. At the bottom, how to write the pressure? Look, this is very, very important for writing the pressure equation. If you want to find out the pressure at the bottom here, then we can start from the top. At the free surface, the pressure is 0. We are traveling in downward direction plus. We are traveling in rho 1 into G into H1. We are at the interface. Now we are further traveling in downward direction. So plus. Now we are traveling in rho 2 fluid into G. If we move in downward direction, it will be positive sign because pressure increases with depth. If we move in upward direction, it will be negative sign. Rho 2 into G into H2. H2 is this depth. Is equal to pressure at the bottom. This is how we can easily write the pressure equation. I hope this is clear to everyone how to write the pressure. At interface, how to write the pressure at the interface? At interface, can you write the pressure at the interface? Can you write the pressure at interface? This is interface. So P at the interface can either be written as rho 1 G H1, that is correct, or pressure at the bottom. Pressure at the bottom we have already calculated. We are traveling in upward direction minus rho 2 G, because we are traveling in upward direction, pressure decreases, minus rho 2 G H2. This is the pressure at the interface of rho 1 and rho 2. Either we write it as rho 1 G H1, or we can write pressure at the bottom minus rho 2 G H2. If we put the value of pressure at the bottom here, then you will simply get rho 1 G H1. Yes or no? Rho 1 G H1 plus rho 2 G H2 minus rho 2 G H2 will simply be rho 1 G H1. This is how you can play with the pressure equation. This is known as pressure equation. You can easily write the pressure equation. All right. So before moving forward, there is an important information. Those who were not there in yesterday's session, today at 7:30 p.m. there will be a workshop, free workshop conducted by Rakesh Talreja sir regarding GATE 2025. So do not forget to join this workshop at 7:30 sharp after this class. It will help you to improve your strategy of preparation, and you just have to register yourself before attending the session. The link is already there in the description box. And on 14th of April, mark the date in your calendar, between 9 a.m. to 9 p.m. there will be the scholarship test for GATE examination, and based on your performance in the scholarship test, you can avail up to 90% scholarship or the discount in our courses. It will help you to have your preparation in organized manner with your full potential. So the link for registering yourself for a scholarship test is also there in the description box. So let us now move to the YouTube manometer. Let us talk about YouTube manometer. YouTube manometer is having the shape U. The shape of the manometer. What is a manometer? Manometer is a static pressure measuring device. Manometer is a pressure measuring instrument. Pressure measuring device. It measures the static pressure. It measures the static pressure. And why it is called as YouTube? Because it is the shape is of U. This is having a U shape. And there are two fluids. One is the manometric fluid, which is having more density. Then another will be the fluid in which we want to find out the pressure. Now, both the limbs are open to the atmosphere. Both the limbs are open to the atmosphere. Both the limbs are open to the atmosphere. So pressure is P atm in both the limbs. Look, try to understand. There are two limbs. There are two limbs. This is called as left limb. Left limb or left leg, and this is called as right limb or right leg. Left or right leg, right? And this liquid is manometric. This is the manometric liquid. There is already a liquid in the fluid. This is the manometric liquid. The density of the manometric liquid is rho m. As long as P1 and P2 are equal, if both the limbs are open to atmosphere, so pressure in the left limb will be same as the pressure in the right limb. As long as P1 is equal to P2, according to Pascal law, the level of manometric liquid in both the limbs will be equal. The level will be same. Now, if P1 is greater than P2, if the pressure at 1 is greater than P2, then there will be a downward deflection of manometric liquid from the initial level. This is the initial level. Because P1 is more, so there is a downward deflection of manometric liquid in the left limb, and there will be an upward deflection of manometric fluid in the right limb. Are you getting it? And if P1 is less than P2, if P1 is less, P2 is more, then there will be a downward deflection of manometric liquid in the right limb, whereas there is an upward deflection of manometric liquid in the left limb. This is the situation of manometric liquid. This is rho m. This is rho m. So depending on the pressure variation, if P1 is more or P2 is more, then the deflection of the manometric fluid will be there. And what is the relation between A and B? What will be the relation between A and B? We can easily find out. Look, as the density of manometric liquid remain constant. Sorry, as the volume of the manometric liquid remains constant, we are not adding or removing any manometric liquid. Initially, the level will be same. This is the initial level, let us say. As long as both the limbs are open to atmosphere, initial level is same. This is the manometric liquid. This is the manometric liquid. Now, if P1 is greater, this is, let us say, P1, this is P2. If P1 is greater than P2, then there will be a downward deflection of manometric liquid. Yes or no? And there will be an upward reflection of manometric liquid in the right limb, isn't it? So whatever the volume which is decreasing in the left limb, manometric liquid will be equal to the volume of manometric liquid increasing in the right limb from the initial level, yes or no? This is the area of the left limb, this is the area of the right limb. So we can say, can we say A1 into A is equal to A2 into B? Yes. This is the relation between A and B. Or if it is circular, pi by 4 d1 square into A is equal to pi by 4 d2 square into B. For circular tubes, for circular limbs, the cross section is circular. Then, and one is circular, another is rectangular, then A1 will be pi by 4 d square, A2 will be L into B. So we can compare this. But if A1 is equal to A2, for an example, if the left limb is having the same area as right limb, then we can comfortably say A will be equal to B. Or let me first write. So A plus B will be the manometric fluid deflection. This is the total deflection of manometric liquid after developing the pressure difference P1 and P2. So this is called as X. The left limb is having the level here, the right limb is having a level here. So X will be equal to A plus B. That is called as manometric fluid deflection. This is called as manometric fluid deflection. This is called as manometric fluid deflection. And if A1 is equal to A2, then we can say A is equal to B, which is X by 2 each. Or we can say X will be equal to either 2A or 2B if A1 is equal to A2. But if A1 is not equal to A2, if A1 is not equal to A2, then this is the relation by which we can develop a relation between A and B, by which we can calculate A and B separately. If A is given, we can calculate B, and from here we can find out the manometric fluid deflection, right? This is called as U2 manometer. So using this concept of Pascal law and hydrostatic law, using the concept of Pascal law and hydrostatic law, let us write the pressure equation for the given situation. Look, how to write the pressure equation. For an example, initially the level was here. Initially the level was here. This was the initial level. But as soon as the left limb is attached to a pipe, this is the pipe. Left limb of the manometer is attached to a pipe, and the objective is to find out the pressure here. The pipe is having the fluid of density rho F, and rho M is the manometric fluid, density of the manometric fluid. And this is the manometric fluid deflection. So when P is greater than P ATM, then if from the initial level there will be downward deflection in the left limb and there will be an upward deflection in the right limb. And this, the total deflection of manometric fluid is X. This is X. And let me call this to be Y. This is given. This distance is Y. The right limb is open to the atmosphere. Right limb is open to the atmosphere. So how to find out the pressure? Pressure equation to find P, or expression for P. Pressure equation is used to find expression for P. For the expression for P, one is known as jumping method. What is the meaning of jumping method? In jumping method, what we do is we jump through the continuous mass of same static fluid in a horizontal plane. Single static fluid and horizontal plane, according to Pascal law, they will have same pressure, isn't it? So we apply the Pascal law for jumping. We will jump from one point to another in such a way that the point will have same pressure. Let us try to understand how. The pressure here will be P, which is unknown, and because in the manometer in the manometer the fluid is all static. Both are static fluid. Rho F and rho M, this is static. Both are static fluid. So according to Pascal law, here also the pressure will be P. At the same height, the pressure remains same in a static fluid. Now we are traveling in downward direction. Pressure increases. We are traveling in rho F fluid into G. We are traveling up to a distance Y. Depth Y. Now, can we jump from here to here? Can jumping be allowed? Are these 2 points having same pressure? Then only jumping will be allowed. So, you need to check whether these 2 points are satisfying all the condition of Pascal law, yes or no. Can we jump from here to here? Yes or no? Y for yes, N for no. Can we jump? Tell me. Because these 2 points are not part of a single fluid. These 2 points are not part of a single fluid. If we cannot join them from the top. We cannot join them from the top. They cannot be joined from the top. But if we join them from the bottom, we need to travel in multiple fluids, rho F and rho 2, rho F and rho M. That is why jumping will not be allowed here. We are not going to jump here. What we are supposed to do, we need to move further in downward direction, plus. And we are still traveling in rho F into G into now X. Here, can jumping be allowed between these 2 points? Can we jump? Yes, now we can jump. So, if we jump between these 2 points, we are here now in the right limb, but we are still having the same pressure value. Are you getting it? We will not change the expression for the pressure, but we will jump from left limb to the right limb. Yes. Now we are traveling in upward direction because we know the pressure in the right limb. We are traveling in upward direction, pressure decreases with height. Upward direction pressure will always decrease, so there will be a negative sign, and we are traveling in manometric fluid, rho M into G, and we are traveling up to a height X, and here we are having the atmospheric pressure. So whatever the expression written should be equal to P ATM. That is because P ATM is not taken as 0. That is why we are getting the value of absolute pressure in the pipe. And if we want to calculate the absolute gauge pressure in the pipe, then absolute minus ATM will be the gauge pressure. So the gauge pressure will be equal to P absolute minus P ATM, that is equal to rho M into G into X minus rho F into G into X plus Y. Do you guys understand this pressure equation? We could have written like this, look, or we could have started from P ATM. P ATM is the pressure at the top in the right limb. We are traveling in downward direction, then plus we are traveling in rho M into G into X. Now we could have jumped from right limb to the left limb. Here, now we are traveling in upward direction, minus we are traveling in flowing fluid into G into total height is X plus Y. We are here, and that is equal to P. According to Pascal law, that is equal to P. Because we are not taking atmospheric pressure to be 0, that is why we are getting absolute pressure. So gauge pressure is equal to absolute minus ATM is gauge pressure, simply rho mgx minus rho f into G into X plus Y. Do you guys agree this jumping technique? Are you guys comfortable with the jumping method? Anybody is having any doubt in understanding the jumping method? Please do let me know. कुछ नहीं करना है, बस जंप करना है इधर से उधर. We need to jump from left limb to right limb और from the right limb to left limb. क्या हमें ध्यान रखना है कि जंपिंग उन्हीं 2 पॉइंट्स के बीच में अलाउड है जिन 2 पॉइंट्स का प्रेशर सेम है. एंड प्रेशर कैसे सेम होगा? व्हेन द पॉइंट्स आर जॉइंड बाय द कंटिन्यूअस मास ऑफ द सेम स्टैटिक फ्लूइड एंड they are lying in the same horizontal plane. I hope this method is all clear to everyone. There is one more method that is known as the datum line method. It is only the difference of the name, but concept wise pressure equation always involve Pascal plus hydrostatic law. It only involves Pascal and hydrostatic law. सिर्फ पास्कल और हाइड्रोस्टैटिक लॉ की अगर आपको क्लैरिटी है, so it does not matter whether you are using the datum line method or a jumping method. Again, the same diagram, the similar situation, we are going to find out the value of P here. This is the pipe having the density rho F. This is the manometric fluid, and the manometric fluid deflection is X. Why it is X? Why there is a downward deflection in the left limb? Because P is greater than P ATM, and this height will be Y. This will be Y. Now, how to use the datum line method? Look, according to datum line method, we draw a horizontal line. Now we are not jumping. We draw a horizontal line and calling it a datum line. और horizontal line कैसे होनी चाहिए? Through the continuous mass of same static fluid. एक horizontal line ऐसी होनी चाहिए, horizontal plane, continuous mass means single fluid. वो लाइन सिंगल फ्लूइड से पास करनी चाहिए और स्टैटिक फ्लूइड होना चाहिए. अकॉर्डिंग टू पास्कल लॉ प्रेशर विल बी इक्वल फॉर ऑल द पॉइंट्स लाइंग ऑन द डेटम लाइन. दैट इज द पास्कल लॉ. लगा दिया हमने पास्कल लॉ. दैट इज व्हाट इज आवर पास्कल्स लॉ. और वो हॉरिजॉन्टल लाइन इज योर मर्जी, आपकी चॉइस है. आप किसी भी हॉरिजॉन्टल लाइन को डेटम लाइन बोल सकते हैं. आप यहां भी बना सकते थे, आप यहां भी बना सकते थे, आप बॉटम पे भी बना सकते थे. ये मेरे को ज्यादा अप्रोप्रिएट लगती है कि यहां पे एक्स्ट्रा हमें इंफॉर्मेशन की जरूरत नहीं है. वरना ये डेटम लाइन बनाते तो ये हाइट हमें अज्यूम करनी पड़ती. अगर बॉटम की डेटम लाइन होती तो हमें ये हाइट अज्यूम करनी पड़ती. बट क्योंकि हमने डेटम लाइन इसी को ले लिया है, इन दोनों पॉइंट का प्रेशर सेम है. लेट मी कॉल दिस पॉइंट टू बी M, लेट मी कॉल दिस पॉइंट टू बी N. सो वी कैन से PM and PN will be equal. Yes or no? PM and PN will be equal. PM कैसे लिखेंगे? Start from the left limb. The pressure, unknown pressure is P. This point will also have the pressure P. Here also pressure P. We are jumping actually. We are jumping from this point to this point. Datum line method में भी we are doing jumping in the first step. Then we are traveling in downward direction. So plus we are traveling in rho F fluid into G into distance X plus Y to reach at point M. Pressure at point M is PM, let us say. Similarly, start from the right limb. Pressure here is P ATM. Start from the P ATM. We are traveling in downward direction. Again plus. Now we are traveling in manometric fluid into G into X. And we have reached at Pn, and according to Pascal law, Pm is equal to Pn. So if RHS are equal, LHS must also be equal. Yes. So we can say implies P plus rho F into G into X plus Y should be equal to P ATM plus rho M into G into X. And this will give you the absolute. Why? Because P ATM is taken into consideration. Absolute minus atmosphere is equal to gauge pressure will be equal to rho mgx minus rho f into G into X plus Y. Same expression but with a different approach. Same expression we will be getting for P, but it is slightly different approach. We are not jumping here, but we are identifying the points again which are having the same pressure, and we are drawing a horizontal line passing through those points and calling it is a datum line. सेम है, कुछ भी नहीं अलग किया है. डाउनवर्ड मोशन प्लस साइन, अपवर्ड मोशन नेगेटिव साइन, राइट. एंड ट्रेवलिंग इन रो एम, पुट रो एम जी एक्स. ट्रेवलिंग इन रो एफ, पुट रो एफ जी एक्स. फर्स्ट स्टेप, आइडेंटिफाई द पॉइंट्स विच आर हैविंग द सेम प्रेशर, चाहे वो जंपिंग मेथड हो चाहे डेटम लाइन मेथड हो. देन use the hydrostatic law to write the pressure equation. I hope this is clear. Now it is your turn. Now it will be your turn. Can you write the pressure equation for this? Can you find out the value of P? There is a fluid here, rho F. Here it is rho F, and this is the manometric fluid. And the manometric fluid deflection is always denoted by X. And this distance will be, let us say, y. This is y, and the other limb is open to atmosphere, P atm. Can you find out the gauge pressure in the pipe? Can you write the pressure equation for the gauge pressure in the pipe? Can you write the pressure equation? Now everybody use your pen and notebook and try to write the gauge pressure expression. Everyone, please try to write the gauge pressure expression. Either use the datum line or jumping method. The first step, what is the first step? Identifying those points. Here the pressure is P atm because it is open to atmosphere. Here the pressure is P atm. Do you agree here also the pressure will be same? These are the 2 points. These will be the 2 points which will be having the same pressure. These 2 points will be having the same pressure. Whether you talk about a jumping method or datum line method, start from P, color is not good, start from P, then starting from P, then jumping from here to here, because these points are in the same line, so we will not change anything. Now traveling in downward direction plus traveling in rho F into G into Y. Here now we are traveling further in downward direction again, plus now we are traveling in rho M into G into X here, and that will be the pressure here, that is equal to P atm. And we have not taken atmospheric pressure to be 0, so this will give you the absolute. Minus P atm is equal to the gauge pressure. It will be minus of rho F G Y minus of rho M G X. It is a negative gauge pressure. Minus this will be the expression. Why it is a negative? Negative is also called as vacuum pressure. Negative gauge pressure is also known as vacuum pressure because बहुत बढ़िया, minus P atm is equal to 0. Kumar, is equal to P atm. You should have written is equal to P atm. Very nice, Kumar. Well done. Vacuum pressure because P is less than P atm. It is a negative gauge pressure. That is why the deflection is in upward direction. Manometric fluid deflection will tell you whether it is a negative gauge pressure or positive gauge pressure, right? So this is how you can easily write the pressure equation, right? If anybody is having any doubts, please do let me know. So for clearing any competitive examination, 2 things are always important. One is your hard work, dedication, your enthusiasm, as well as equally important is the right guidance. As you can see, those who joined us, those who trusted us and were ready to do hard work, have done really hard work, had secured good ranks, great ranks in the GATE 2024. So if you want to crack the GATE examination with the best possible rank, with your best possible potential, then you can always join our vision courses. Here we give you the right strategy in an organized manner. We discuss the concept or the syllabus in organized manner through the live classes. We provide you the recorded lectures. We provide you the study materials as well. We provide you the quizzes, everyday quizzes, and mock test for practicing lot of numericals which are having the difficulty level as that of the GATE examination. So if you are interested to join our vision course, then there is a counselor's number. You can call the counselor number, or you can just fill the counseling form which is already there in the description box. Our counselor will call you one-on-one and will discuss everything about your preparation and everything about the vision courses. All right. Now, one more question before we end our session. Sometimes the U2 manometer is attached inverted. Sometimes the U2 manometer is attached inverted. There are two tanks, 1 and 2. This is tank number 1. This is tank number 2. The question is to find out the pressure difference at the floors of the two tanks 1 and 2 H1 in figure. Right? So this instrument is called as inverted U2 manometer. We call it as inverted U2 manometer. Sometimes the manometer is attached in inverted arrangement. It is called as inverted U2 manometer. उल्टा लटका दिया है उसको. Inverted U2 manometer. And in that case, manometric fluid density should be less than the flowing fluid. Other fluid. Here, rho 3 should be, rho 3 is the manometric fluid. Rho 3 should be less than rho 1 and rho 2. Right? So, first of all, the first step is to assume. We need to find out the pressure difference at the floors of two tanks 1 and 2. Let me assume the pressure here as P1. Let me assume the pressure at the bottom of tank 1 as P1. Let me assume the pressure at bottom of tank 2 is P2. So P1 and P2 are assumed to be pressures at flows of tanks 1 and 2 respectively. P1 and P2 are assumed to be the pressure at flows of tanks 1 and 2 respectively, right? Now, let me write the pressure equation using the jumping method. Now, for jumping method, we need to identify those points which are having the same pressure. Do you agree these 2 points will be having the same pressure? Yes or no? So the jumping will be possible between these 2 points. These 2 points will have same pressure because they are joined by the continuous mass single fluid. These 2 points are joined by the single fluid. The jumping will be possible. Now it is not done, Chandrasekhar. We will discuss this question and then we will stop. Right? Now, how to write the pressure at this location? Start from P1. Pressure at the bottom of tank 1 is P1 because we are traveling in upward direction. So minus, do not forget to put negative sign. We are traveling in rho 1 fluid. Rho 1 into G into this height is H1. Here, H1. Now we are further traveling in upward direction. Again minus. Now we are traveling in rho 3 fluid. Isn't it rho 3? Rho 3 into G into this height. How much is this height? Isn't it H2 minus H1? Right? So it will be H2 minus H1. Now we are here. Now we can jump from here to here. Right limb. There will not be any change. Now we are traveling in downward direction. And now the sign will be plus and the fluid will be rho 2 into G into to reach point 2. We are traveling H2. Is equal to our destination P2 is equal to P2. So this is our pressure equation. We can easily find out the pressure difference. P2 minus P1 is simply rho 2G H2 minus rho 1G H1 minus rho 3G H2 minus H1. This is our expression for P2 minus P1. This will be the expression. Similarly, you can use the datum line method. Look how to use the datum line method. Again, the datum line can be called this line. This horizontal line we can call as datum line because the pressure will be equal. The pressure will be equal, right? So again, pressure at the bottom is P1, pressure at the bottom of the tank 2 is P2. So P1, we are traveling in upward direction minus rho 1 G H1. Then we are further moving in upward direction minus rho 3 G H2 minus H1. That is PM. This is, let us say, point N is equal to, how to write Pn? This is N. Start from P2. P2 is the pressure at the bottom of tank 2. We are traveling in upward direction minus, we are traveling in rho 2 into G, simply H2. This is Pn, and according to Pascal law, Pm is equal to Pn. Yes. So again, you will get the same result. This is the datum line method. Pm will be equal to Pn. Or some people use this as well. As we know, Pm is equal to Pn is equal to P. Pm and Pn are constant. This is point M, this is point N. So how to write P1? You can write P2, another method, the third method. So look, from point M, the pressure is P. We are traveling in downward direction, so plus, we are traveling in rho 3 fluid into G into H2 minus H1. We are here, we are further moving in downward direction, plus, we are traveling in rho 1 into G into H1. What is the value at the bottom? That is P1. Similarly, start from Pn. Pressure at Pn is P. We are traveling in downward direction, plus we are traveling in rho 2 into G into H2 because we are traveling in downward direction to reach P2. So here this expression will be equal to P2. Subtract equation number 1 and 2. Subtract equation 1 from equation number 2. If you subtract, the right hand side will become P2 minus P1. The left hand side will be, this P and P will getting cancelled out. Then it will be rho 2 G H2. Then minus rho 1 G H1 minus rho 3 G H2 minus H1. So this is how we can write the pressure difference. Every time you will get the same result, isn't it? Every time you will be getting the same result. This is how you can easily write the pressure equation. So I am giving you one assignment for regarding this session, whatever we have discussed in this. So you need to solve this question and share me the answer through the comment section or bring me the answer in tomorrow's class. If you have any difficulty, we will discuss the solution of this. Otherwise, tomorrow we will be meeting for tomorrow at 6 p.m. We will be discussing about very important topic of hydrostatic fluid statics, that is hydrostatic forces on a plane surface as well as hydrostatic forces on a curved surface. So come a little bit prepared, read a little bit about the hydrostatic forces. It will help you to improve your understanding in tomorrow's class. And not only on YouTube, we are running free series, free sessions on our Byjus exam prep app also for all the branches for GATE 2025. So what you need to do is you just download our Byjus exam prep app from the Google Play Store, or there is already a link, bit.ly link in the description box. You just download the app and you can start attending the free sessions and the quizzes. You can start attempting the quizzes for your efficient preparation. All right. So do not forget to go through the description box and do not forget to like and share this session. And if you are not part of my Telegram channel yet, do not forget to join me on the Telegram, which is Mechanical by Chandrasekhar. So that is all from my side. Thank you very much for joining in, for being part of this session. See you tomorrow at 6. Till then, enjoy, take care, have a good day and a great career ahead. Thank you once again and Jai Hind.